So the title of our notes is Segments and Circles. And this is at a 8.5. This is our last section in Unit 8. And like we looked at angles yesterday, now we're putting the angles aside. We're just going to look at segment lengths. But we're going to draw some similar pictures here. So we got four cases to look at. And one case is inside the circle. And so draw a circle with two chords that intersect each other. And we'll come back to that picture in a second. And then three cases that happen outside the circle, or a mixture of outside and inside, but the angle is going to happen outside the circle. So one is when we have two tangents to the circle. One is when we have a tangent and a secant. And one is when we have two secants. Okay. And we're going to start with the inside of the circle. So if we have two chords that are crossing at some point, they have a point of intersection, they divide each other into two parts. So one chord gets split into part A and part B, and the other chord would get split into part C and part D. And those, let's say those are lengths of those chords. There's a relationship between those lengths. And it's actually a nice one. It's A times B is equal to C times D. So if you take whatever the two segments that one chord make up one chord and multiply those together, you get the product of the other two segments that were split up. So that's a nice result, and we're going to use that. If we were to prove that, it would come through similar triangles and proportions and cross multiplying. But I'm going to bypass that, but this is the result we're going to use. And I want you to know that result. In terms of outside circle, we looked at a result already with two tangents, and I just want to restate it here. So if this side length is A, this side length is B, what did we learn about A and B? Anybody remember? They're congruent to each other. And we showed why. If we drew from the center of the circle, we get two congruent triangles. And we saw that those were congruent to each other. We also had some problems where we would draw like a quadrilateral around that circle and try to find the perimeter, and we had to use that idea that that point is the same distance to the circle in both directions. Okay. Look at the tangent and the secant. Let's say this is A, this is B, this is C. Okay, this is new to us. Second formula I want to give you. The relationship between these side lengths is this, that A squared is going to be equal to B times, you would like to say C, but it's not C. It's actually the full length, B plus C. And if we have two secants, a secant split into two pieces, we'll call this piece A and B, C and D. The relationship between these side lengths is this, that A times the full length, A plus B, is equal to C times the full length, C plus D. Okay, so there's 3 cases that are new to us. These are the only 3 cases that we're going to have to memorize and be able to work with. 2 chords crossing each other, a tangent in the secant case, and then the 2 secants. So I want to go over some examples together, but I'm thinking that you might, and it might be best for you if we do some examples from our homework. You guys okay with that? Because they're still going to apply these 3 things, and so I'll work with you and kind of demonstrate on a few problems how to use these things, okay? So let's take out that homework. Oh, and you need that homework. Let me get that homework to you. Give me a second. Okay, so from our homework, any requests? Yeah. Oh, you didn't get a homework. You need one. Okay. But any problems that you'd like me to go over, or do you just want me to pick one? 7. I hear 7, and I hear 7 again. So let's start with 7. 7 looks like a fun one, doesn't it? Okay. Oh, it disappeared. Where'd it go? Try that again. Okay, on number 7, are we looking for a side length? Or are we looking for an angle? Because eventually there's 2 types of problems here. We're looking for an angle or side length. So this is a side length problem. We're looking for AE. We've done this in the past. And before in the past, how did we find side lengths? What did we try to create? Right triangles, right? So up until this point, a right triangle is the only way we could find a side length. Now we have 3 other options too, okay? So in this case, we're not going to be able to make a right triangle, so we're going to have to work with one of the 3 other options. So with the 3 other options, there's the 2 chords, there's the 2 secants, and then there's a chord and a secant. Which one do you think we have to use in this 7? Which one would fit this case? Even though it doesn't fit perfectly, which one do you think we would have to use? And you could look at those formulas I just gave you. The 2 chords, 2 secants, or the secant and the tangent. So if you go with the secants or the tangent, you have to somehow this has to extend outside your circle. If you go with the 2 chords, then everything stays in the circle. You know what I'm saying? The difference there? And so there's nothing outside of the circle, right? And if there's nothing outside, then you're going to want to stay inside. Okay? Problem is, how many chords are drawn in here? 1. There's only 1 chord. Remember, a chord goes from the on the circle to on the circle, right? So there's only 1 chord here. So we're going to have to draw that second chord. Do you have an idea what that might look like? It's going to be this piece right here, right? And would that be a diameter? Yes, because we're given that A is the center of the circle. So now we have our 2 chords, and then you got to keep in mind, what's our formula say? And don't memorize A times B equals C times D. Memorize what parts of the chords. So like memorize like this little piece right here times this piece right here is going to equal this long piece right here times this small piece down here, right? That's what the formula says. That those 2 chords will cross and they'll split each other into 2 separate pieces, and you multiply those pieces together, and those products will equal each other. Okay? So let's try to fit those into our formula. And then we're given some stuff. So dB is 3. All right, that's a piece I want. I'm going to put it right here. Do we know the green part, BC? It's 12. All right, so we have 1/2. 3 times 12 is equal to the other part, which is the blue and the purple. Do we know either the blue or the purple? No. What we do know is the distance from A to B, which is not the full blue, it's just a piece of it. I'm going to put it there. Let's make that 8. And the rest of it feels like, what do we do here, right? So let's make the purple part X. And you'll see in a second why I'm doing this. So if the purple part's X, what else can we say about our picture? What's that? X plus 8 would be the radius. Good, because A is the center, and so we have 8 plus X is the radius. So what else would be X plus 8 in our picture? A to E, right? And that's important for us to know because that's what we want to figure out. So if I can find out what X is, I just add 8 to it, and I have my answer. It's also the distance, like I'll just put a point D here. It's also the distance from, sorry, we already have a D. Let's go F. It's also the distance from A to F, which would also be another X plus 8, right? Because that's a radius as well. So wherever the radius is it's going to be X plus 8. And that's another thing. You just want to train your eyes to just to know that and look for a radius or radii. Okay. So what's the length of the blue part now? X plus 16. Because we got an X plus 8 plus another 8. Right? So X plus 16. And so now we've used our formula to set up something we can solve for X and we can get to this answer. Okay. So you distribute, you get X squared plus 16X. Go ahead and solve that. You get two answers. You get X equals 2 and X equals negative 18. So what's our final answer? 10. Because remember what the question is, right? The question is what's AE? And we said AE is X plus 8. And 2 is the value we want to keep because negative 18 is going to make our radius negative. And so you put 2 plus 2 in for 8 and you get 10. 10 is my answer. Okay. What's another one on the first page? You guys are all 3 periods are picking the same problems. You guys are on track. All right. Those are good ones to pick though. Okay, so here we're looking for ED. Okay, and I'm going to highlight ED, the length. That's what I want to find. So which formula do you think we're going to use to find that length? The 2 secants, right? Which says that length times the full length is equal to df times the full length from D to G. Right? So that's what we need to fill in. So I'm going to call DEX because that's what I'm after. So x times something, the green part, is equal to DF. Do we know DF is 3? Okay. So 3 times, do we know DG or FG? FG is 5. So what's the full purple? 8. So I'll put 5 plus 3 so you see where it came from, but it's 8, right? So this is kind of nice. We've almost got it filled out except for the green part. And the green part's kind of holding us back. We're not told what EA is. We are told that AC is 8 and that EC or CE is 6. So it'd be nice if that were a right triangle, we could find the hypotenuse, but I don't know, is that a right triangle? B is the center of the circle. So AE is a diameter. So that means this is 180 degrees. So that means this angle is 90. So it's an inscribed angle. So it is a right triangle. And so let's solve for this, this side length. I'll call it y right now. So we got y squared is equal to 8 squared plus 6 squared, which is 100. So y is going to be 10. So what's the green length? Not 10, x plus 10. Careful there, okay? So now we have a formula that we can use to solve for x, and x is what we're actually after, and we got it, okay? So remember, finding side lengths, Pythagorean theorem helped us here, and then those 3 formulas that I gave you can help you. All right, guys. If you need extra help here, I'll be here at lunch.